Okay, so again, just to make it clear what's happening here, if behaviors are clustered under traits, okay, priming the trait should prime, activating the trait should prime behaviors. Okay, that's the general prediction of this model. So what Klein and his colleagues did was to bring subjects in and basically put them in an experiment about their mothers. Okay, all these guys had mothers. Okay, so the target person is a mother, and he presents the Klein presented subjects with a list of the trait adjectives, and simply asked to check off which ones were characteristic of the subject's mothers. And every mother is different, right? So everybody checked a different set of lists. Then Klein had a set of behaviors that are representative of each of these traits available. These were then, the trait terms were then presented to the subjects in one of three conditions. They were either asked to define the trait, so I put up sociable, and I say, what does that mean? Okay. Or I ask you, does it describe your mother? Is your mother sociable or not? Yes or no? Or I ask you to remember an event involving your mother, the time you went to a wedding and your mother was the life of the party, or something like that. Okay, it doesn't really matter. And what they did was to compare subject, they were always recording response latency here, basically doing a priming experiment, so they compare the subject's performance on any trial with the subject's performance on the immediately preceding trial. And what's critical here is the relationship between trials where the subjects had to determine whether a trait described their mother, and trials where they had to remember an event in which the mother displayed the particular kind of trait. And you can do this with anybody, right? You can do this with your sister, you can probably do it with your dog. They just selected mother for some reason, probably edible. Okay, so here you go. Okay, what's interesting here, they broke this up into traits that were highly descriptive of the person's mother and traits that weren't descriptive of the mother. And this is the most important thing. We're looking at response latencies here. Okay, and what you can see is that if the target task, the way this is set out, the target task, the task on trial N, is either to describe the mother or remember an episode involving the mother. Okay, then the priming task is either the definitional task, which is kind of a control, or remember an episode, or is the trait descriptive. And what you can see here is that there is no priming effect when subjects are asked to describe the mother, is your mother sociable, on the target task of remembering a time when your mother is sociable. So deciding that your mother is sociable or not has no effect on remembering an episode in which she behaved sociably. Okay, that should not happen if behaviors are organized underneath the traits that they represent. They got a slightly different result for these traits that are less descriptive of the mother, but we don't have to worry about that right now. The critical thing here is that there was no effect. This is one of the rare times in the history of psychology where someone was actually able to publish an experiment that got no effect. Usually editors don't like this. Okay? The reason that he was able to do this is that he was testing a clear prediction of a particular theory, where the null effect, the negative result, actually tells us that the theory is wrong. Usually if you just do a study and you don't get an effect and you send it in, the editor will send it back and you say, just give me something better than this. But in this case, because there was a clear hypothesis being tested, and the experiment gave very clear results. I mean, there's just nothing going on there at all. Very clear results that were contrary to the theory. Klein was actually able to get this thing published. Okay, so forget this. So what are the implications? Well, it turns out that retrieval of highly descriptive traits does not prime retrieval of behaviors that reflect those kinds of traits. This is not what's supposed to happen if person memory is organized by traits. But it is exactly what you would expect if trait and behavioral information, episodic and semantic information, were represented in memory independently of each other. I don't want to go into the less descriptive traits for now. That's basically a detail that's not relevant to us. Okay, so now we've got an even better picture of what the structure of person memory looks like. Yes, as far as these associative network models are concerned, people are represented as nodes in the memory network. If you know somebody named Judy, especially if you know her well, you've got a Judy node in your memory network. And fanning out from that are all the things that you know about Judy. So trait information about the person and behavioral information about the person are all represented themselves as nodes that fan out from the person node. But, and here's the critical thing, trait and behavioral knowledge are represented separately from each other. Behaviors don't fan out from the traits. Traits and behaviors fan out independently in this network. Now, I'm going to talk about this later on when we talk about social neuroscience, but just in passing, I'll mention that there's yet a third piece of evidence for this proposition. I actually turned out to have a little bit of time. The first piece of evidence is people don't cluster person memory according to traits. Okay, that tells us that trait and behavioral information is not connected to each other. Retrieving information about traits does not prime retrieval of information about behaviors. That's the second piece of evidence that tells us that trait and behavioral information are represented independently of each other. The third kind of evidence, and this is also work that Stan Klein, the Santa Barbara Stan Klein did, is that repeated these kinds of studies with amnesic patients. Patients who, by virtue of some form of brain damage, can't remember any specific episodes in their lives, like patient HM. Nonetheless, these patients retain some self-knowledge. They retain some knowledge of what they are like in general. So you can have somebody, like if the psychologist who worked with HM had ever actually asked him this, which they did not, okay, you can take somebody like HM and say, what do you remember from the last couple of years? And he'd say, well, nothing. Remember, I'm amnesic, right? But if you say, well, kind of what do you like? He'd say, well, you know, I'm kind of introverted, and but I do like people. I'm just not very sociable, and I'm friendly when people talk to me. He's actually able to give an accurate description of himself, despite the fact that he can't remember anything he's done since he was 18 years old. And this is a very common result in amnesic patients. There are even cases of amnesic patients who not only lost their memories when they suffered brain damage, like the famous patient KC. Again, I'll show you this in detail later. KC doesn't remember anything since he fell off his motorcycle and hit his head. Wear your helmet. Okay? Doesn't remember anything. But it turns out that presumably as a result of his brain damage, he hit his frontal lobes, okay, as well as everything else. Presumably as a result of his brain damage, his personality actually changed. So before, he was a very extroverted guy. That's why he was riding the motorcycle. After the accident, he became a very introverted guy. And if you ask Casey after his accident what he's like, well, I'm pretty introverted. He knows what he's like in general, even though he can't remember any particularly introverted thing that he's done. So again, that's neuropsychology provides yet a third piece of evidence that suggests that the trait and behavioral information are represented separately in memory. Now, since I have time for this, okay, that's what we seem to have. Okay, this is basically how knowledge about a person seems to be represented in memory, where there's a node and semantic information like he's kind and thoughtless fan out independently from episodic information, like he rescued the kitten and he cursed the salesgirl. Okay? Now, there are actually a couple of different ways to think about this. Okay? There are a number of different architectures that can be used to represent the person memory. What we've been talking about is basically what's known as a symbolist architecture, where there are nodes representing symbolic information like kind and thoughtless and curse the salesgirl and so on. So you got these propositions, okay? But there is, and that's what that one looks like. There is another view of person memory, which is not very popular, but which is a perfectly good view of person memory. Somebody in here might someday figure out how to test this, where you don't actually have any semantic knowledge about the person, trait knowledge about the person in memory at all. But rather, what you do is, if you're asked what a person is like in general, you compute that information online based on what you can remember about his or her behaviors. Okay? So if I say, is James Bartlett kind, what you do is you retrieve information about James Bartlett and you remember that, oh, he rescued the kitten and he adopted the child, therefore he must be kind. If I ask you, is James Bartlett thoughtless, you retrieve information about James Bartlett, oh, he's the guy who caused the accident, he's the guy who cursed the salesgirl, yeah, I guess he's a thoughtless kind of person. This is a very plausible model for the representation of person memory. It's the one that's implied by a theory in social psychology called self-perception theory, which basically says that we don't carry around information about general traits and attitudes. All we do is carry around information about specific episodes. And if we have to say something about people in general, we compute that the answer to that question basically online. I think this is a very unlikely model for person memory. And the reason for that is we know from work on the schematic processing principle that it makes a difference if you've already got in memory that somebody is kind or thoughtless, because that's the schema that influences how behavioral information is going to be processed. Okay? So it's pretty clear that we have generic information about a person stored in memory, as well as episodic information about a person stored in memory, because the generic information affects the fate in memory of episodic information, and that couldn't happen if we didn't have that information in memory. So just a kind of logical point suggests that we don't have this. I'm going to skip over that, because what I want to do for the last couple of minutes is to get to a further question here for those of you who are neuroscientifically organized, and that is, okay, we have some idea in these kind of abstract associative network models of memory of what person memory looks like. How is that actually implemented in the brain? How is that actually implemented in the sponge of neural tissue that is the physical basis of mental life? Well, when we look at neural models of knowledge representation, basically we're confronted with a choice between two models. Okay, there is first a distributed model, which basically says that any piece of knowledge is represented by a reverberating pattern of neurons that goes over the entire cerebral cortex. Okay, that's the short version of the story, and it comes to us from Carl Lashley and his law of mass action in the cortex, and was popularized by Donald Hebb, Canadian psychologist. The other way to think about the neural representation of person memory is a localist representation, where the nodes that I've been talking about for the last 2 days really correspond to neurons, or something like neurons, very small clusters of neurons, so that, if you will, if you ask me about Judy, I activate not just a Judy node in some abstract associative network, I actually activate a neuron or a small cluster of neurons in my brain that represents Judy. And then activation spreads out, neurotransmitters and synapses and all of that kind of stuff. This is a perfectly plausible model of person memory. For historical reasons, mostly, our understanding of the neural representation of knowledge has favored these distributed models. Okay, not so much favored these localist models. But recently, there has been a revival of what might be thought of as a localist model, because some investigators, these are guys at Caltech and UC San Diego, mostly, have done what's known as single unit recording in the working brain, and they find that there are single units, single neurons or very small clusters of neurons that are inevitably activated whenever a subject thinks about a particular person. This is really very interesting data. Okay, this is work by Quiroga and his colleagues. That's Christopher Koch at Caltech, working with a group of patients with intractable epilepsy. And when you do surgical treatment of epilepsy, what you do is you run microelectrodes down into various parts of the brain to see if you can localize where the seizures are coming from, where they're starting from. And also you run electrodes down the brain. So you think you might want to carve out those parts of the brain. You don't want to hit anything really critical, like you don't want to take out somebody's Broca's area or something like that if you can help it. That's how HM got amnesic. So what they did was they put these electrodes down into these people's brains, 8 active microwires per electrode. So these microwires jut out from the electrodes and presumably are in contact with either single neurons or very small pieces of neurons. And there was a lull in the surgical procedure. Patients didn't have anything else to do. They're awake and conscious, because you're awake and conscious during most forms of brain surgery. So these investigators decided to show these individuals pictures of familiar objects and people, and just see if specific neurons fired every time they showed them these particular pictures. And the selections were based on interviews with patients. They go to the patients and say, what TV shows do you watch? Where have you traveled on vacation? Stuff like that. And then they quick went to Wikipedia or someplace and dug out images to show these people. And what they discovered was one patient, in any event, who had what they called a Jennifer Aniston neuron. This was a patient where there was a particular neuron that fired every time they showed him a picture of Jennifer Aniston, but did not fire when they showed him pictures of other female movie stars. Okay, so here, if you can see this, up here there's about 8 pictures of Jennifer Aniston, and you can see this activity, this neuron firing in response to each of these pictures. But now we've got control pictures of other people and other objects. Here's the Eiffel Tower, and there's no particular activity in this neuron. Call it the Jennifer Aniston neuron. Another patient had a Halle Berry neuron. Okay, here are about 10 pictures of Halle Berry, including Halle Berry as Catwoman. Okay, and we got this neuron that's firing very nicely every time he's seen a picture of Halle Berry, but it's not firing to Jennifer Aniston, and it's not firing to Joe Lieberman, and it's not firing to Dick Cheney, and so on. It seems to be an actual cluster of neurons, in this case not a single neuron, but a cluster of neurons that are firing with whenever the person looks at or thinks about Halle Berry. So the Jennifer Aniston neuron in this one patient was in the left posterior hippocampus. Okay, the Halle Berry neuron in this other patient was in the right anterior hippocampus. Exactly where these things are doesn't really matter. The point is that what Quiroga and his colleagues are claiming here is evidence of some kind of actual localist representation at the neural level. Whether this pans out or not is a question for the future. But people are always asking, whenever we talk about associative network models of memories, how does this actually work in the brain? Okay. Do we have nodes in the brain? Well, what could possibly correspond to nodes in the brain? Well, it's got to be neurons or clusters of neurons. If we really did have people represented as nodes, we might expect to find discrete, localized areas of neural tissue that are responsive whenever we think of or perceive or encounter that individual. Further research is required on this, but the finding is stunning enough that I wanted to share it with you here. The neuroscientists often used to dispute the idea that there's a grandmother neuron, a neuron that fires every time you think about your grandmother. Well, maybe you don't have neurons that fire when you think about your grandmother, but some people have neurons that fire when they think about Jennifer Aniston and Halle Berry, so we can't dismiss the possibility. Okay, next time we'll start looking at social categorization. Have a good weekend. We'll see you next Monday.